Welcome. In this video we will see the different aspects of principal component analysis and when to use it, and we will try to understand this with an example. Suppose you have 10 variables. Let's call it x1, x2, x3. Suppose you have 10 independent variables or features, and you don't know which one to keep in the model and which one to drop. So in that case, principal component analysis helps. So this is also called as unsupervised machine learning technique, and it is also called as a dimensionality reduction technique. So dimensionality reduction means, so among the number of features, among n number of features, we only retain few. But whenever we are reducing the number of variables or features, we also lose information. The main objective of PCA is, even though we are reducing the number of variables, we are not losing much of the information. That is the trade-off. That is what we are trying to achieve in principal component analysis. So let's take this example. So we have 10 independent variables or 10 features, and let's say this person. So we have around 100 observations. Let's say first one value is x1 is 2, the other one is 3, like that 4. For the x variable I am just giving some values. So this is, let's call it 4. Similarly for x10 this is 5. So for 100 observations we have values for 10 features. Okay, so we want to reduce these features. One way is we can directly remove few features which we think or which we know which are not important. So if we don't know that, then we need some other technique. In that case, let's use what PCA does is, principal component analysis tries to find out the principal components in this, let's call it Z1. So it tries to find out Z1 by combining all these features, by giving them loadings. For example, let's the first x1 got 2, this one got 0.5, this one got 0.3. Similarly, this one is, let's say it is 0.5. So how to arrive at this first value for the first observation? In case of first principal component is 2 into 2, 4. This is 1.5. This is 1.2. Similarly for all, let's call it, if we multiply this, is equal to 2 into 2, these two, plus 0.5 into 3. Similarly till 0.5 into 5. So let's say this value is 4. Similarly for all 100 observations we are finding out the value. Let's say this is 8. Similarly for second principal component Z2. So it again gives factor loadings in the similar way, but the value may be different. In this case, let's say this is 0.1, this is 0.8, this is 0.4, this is 1.2. Okay. Now, if we multiply this 0.1 with 2 and 0.8 with 3, we will get another value for Z2, right? So in the similar way, we can find out, since we have 10 independent variables or 10 features, we can calculate up to 10 principal components, right? But if we retain all 10, what is the use of calculating principal components? Instead, we can very well use all these 10 features. So in our case, how to know that what is the amount of variation or how much information in this data set is explained by these principal components? So for that, there is one plot that is also called as scree plot. So it plots the principal components here on the x-axis and explained variance on the y-axis, right? So it says the first principal component, how much variance, if we assume the total variation in the data is 100 or the total information is 100%, how much or what percentage is explained by the first principal component, second principal component. So up to, if we have 10, we will have 10 principal components. So let's say the first principal component, it explains around 80%. Next will be let's say it is 15%, so on. So it goes on reducing, and if we add all these principal component variation, it will be 100%. So we will use, so if we plot this, there will be like a knee joint. Wherever there is the departure from the normal slope, we will select that many. Or if you want to retain 80% of the information is enough for you, then you can go with the single principal component. Or if you want more than 90%, let's say 95%, then you can use these two principal components in the analysis instead of these. So what is the advantage of principal component analysis? One is it helps to reduce the number of variables without losing much of the information. Number two, it is useful when there is multi-collinearity. Suppose the individual variables are correlated. In such cases, it is helpful. And what is the disadvantage? Disadvantage is it assumes that the principal components can be found out or calculated by multiplying and adding. That is, his assumption is linearity. So that is one of the disadvantage of principal component analysis. And in scikit-learn, there is principal component analysis option is there. There you can, and one more thing is, before doing the analysis in scikit-learn, you have to scale it, because it calculates the loadings based on the variance matrix. Suppose let's say x1 is let's say it is in centimeter, and x2 let's say it is in quintals. So it will be 2, 1.5, 3, but it may be like 100, 250, 300, right? So it gives higher loadings to this one, even though it may not be so much important in this data set. So the unit is important, right? If I measure same thing in terms of meter, it will be 1, 2.5, right? Then the loadings will change. So before doing the principal component analysis, we have to standardize it or make it the unit free, and then proceed with the analysis. So this is in brief about principal component analysis.